All right, let's get started. Math 2, this is Mr. T from Clovis High School. We're going to go over Unit 10, Worksheet 6. This is what the worksheet looks like right here. And what we're going to be doing in this worksheet is we're going to be finding the zeros of the graph, or of graphs and of equations that we have, okay? So remember, what are the zeros? The zeros are, we're finding the point or the points where the graph intercepts the x-axis at. Okay, so in this very first one, you can see that we have a graph. It intercepts the x-axis at -1, so that's one of my zeros, and it also intercepts the x-axis at +3. So my zeros in this graph would be -1 and -3. And the way that we like to see you write that would be like this: x is equal to -1, comma 3. Okay, number 2, you can see, so here's my graph right here, here's my parabola. Well, it only intercepts the axis at one point, and that would be at -4. So the zero of this graph is -4. Excuse me. So the way that we would write that is, we would say that x is equal to -4. Okay, so find the zeros from a graph should not be much of a problem. Okay, now the next part is, part 2, is we're going to find the zeros of a trinomial, but we're without a graph. Okay, so what do? So what we're going to do is we're going to factor. Then we're going to set the problem equal to 0, and then we're going to solve it out. Okay? So in number 3 right here, we have y equals x squared plus 7x plus 10. So the first thing that we do is we are going to factor this trinomial out. All right? So a trinomial factors into two binomials, and since this is a plus trinomial, that means my factors are going to be x plus and x plus. Okay, and then I need to find the distinct numbers that are the factors for this trinomial. And the way I do that is I take my last value that I see, which we call our C value, which is 10, and I make a list of the distinct pairs of numbers that multiply to make 10, which are 1 times 10 and 2 times 5. One of those is going to be my distinct factors for my binomials, and it's the one that it is the pair that could be added or subtracted in order to make this middle term number right here, which we call my b value, which is +7. So you can see that's going to be 2 and 5. Why 2 and 5? Because 2 plus 5 is equal to 7. 2 times 5 is also equal to 10. So my factors are x plus 2 and x plus 5. Then what I do is I set this problem equal to 0. Okay? And then what I do is I solve the equation out. So I'm going to kind of split the problem in two. I'm going to take this first parentheses, x plus 2, my first factor, and I'm going to make that equal to 0. And I'm going to solve it by subtracting 2 from each side. So I'm going to get x is equal to -2. So my zeros are x is equal to -2, and I'm going to do the same thing with my other distinct factor, which is x plus 5. I'm going to make that equal to 0, and I'm going to solve it by subtracting 5, so I get x is equal to -5. So my two zeros are x is equal to -2 and -5. Okay? Moving on to number 4 here, we have y equals x squared plus 7x minus 18. So I'm going to find the zeros. So the first thing that we do is we're going to factor the trinomial. We're going to put it into factored form. All right? So it's a plus minus trinomial. So that means my factors are going to be x plus and x minus. All right, now to find the two distinct factors that are going to make my two binomials, I'm going to take my last number, which is my C value, which is 18. I don't worry about the negative quite yet. And I'm going to write out all the distinct pairs of numbers that multiply to make 18. 1 and 18, 2 and 9, 3 and 6. One of those pairs can be added or subtracted together to make my middle term, my b value, which is +7. So you can see that it has to be 2 and 9. Okay, but now it's a plus and it's a minus. So now I know it's 2 and 9 because I can put those together by adding or subtracting to make 7. But now the question is it +2 and -9, or is it going to be the other way around, +9 and -2? Well, I look at this number here. It's positive 7. So that means it has to be the positive 9 and the minus 2. So my factors are x plus 9 and x minus 2. I change the y value into 0, and then I find my zeros. Now, if you notice, whenever I factor into two binomials, my zeros are the opposite of the value that I see here. So if I have x plus 9, that means my 0 is going to be negative 9 for that. Okay, why negative 9? Because negative 9 plus 9 is going to make this equal to 0. Then I go to my other distinct factor, x minus 2. What could I put right here to make that 0? Well, that would be positive 2, the opposite of this minus 2. So my zeros are x equals negative 9 and x equals positive 2. All right, moving it over, we're going to keep doing these. So we're just going to keep factoring, and then we're going to find the zeros of what we have here. Okay, so in number 5, I factor x squared minus 11x plus 18. So I factored into two binomials. This is a minus plus trinomial, so that means my factors are going to be x minus and x minus. Okay. Now to find my distinct factors, I take the number 18 and I write out all the factors, pairs of factors that multiply to make 18. 1 times 18, 2 times 9, 3 times 6. Well, it has to be 2 and 9, because those are the only two that I could add or subtract together to make 11. So my factors are x minus 2 and x minus 9. I change the y to 0, and then I solve. So what would I put right there where my finger is in the place of that parentheses to make it equal to 0? That'd be positive 2. So one of my zeros is positive 2, and my other 0 would be positive 9. You may be thinking to yourself, hey, those are just the opposite of what the distinct factors are, and you are absolutely right. A little bit of a shortcut if you see that. Number 6. I'm going to factor x squared minus 4x minus 12. So this is going to factor into two binomials. And since it's a minus trinomial, my binomial factors will be x plus and x minus. Okay? I then take my last term, my c term, and I'm going to write out all the distinct pairs of numbers that multiply to make 12. 1 and 12, 2 and 6, 3 and 4. Which one of those pairs can be added or subtracted to make negative 4? Okay, well that would be 2 and 6. Now it's a negative 4, so that means the 6 has to be the plus and the 2 has to be the minus. Okay, I change the y to 0, and then if you understand the pattern that's going on to find the zeros, you just take the opposite of your distinct factors. So negative 6 and positive 2 would be my zeros for that problem there. All right, number 7 is going to be a little bit more involved, but not a whole lot, and the reason is because I have a leading coefficient in front of my trinomial. So I need to factor this out. So remember, the first thing that we do is we're going to get rid of that leading number 3, and we're going to move it to the back of the trinomial. And what that does is that's going to create an easier trinomial for me to factor. X squared minus 10x minus 8 times 3 is 24. Okay, then I'm going to factor this trinomial. So I get the trinomial here. All right, I'm going to get two binomials. It's a minus minus, so my factors, my binomial factors are going to be x plus, x minus. All right, and now I'm going to take that last number, which is 24, that's my c value, and I'm going to write down all the distinct pairs of numbers that multiply to make 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, now my middle term, my b value is negative 10. Which one of these can be added or subtracted to make 10? All right, well, in this case, I have a choice to make. And my choice is I could either do 4 and 6, but it can't be 4 and 6 because one of them has to be plus, one of them has to be minus. And I can't get plus 6 minus 4 to negative 10. So I have to go with 2 and 12. Now it's a minus, so that means the minus number has to be bigger. So it's going to be an x minus 12, and it's going to be an x plus 2. Okay, now though what I have to do is I have to divide each of these numbers by the leading number that I multiplied at the beginning. So I'm going to divide each of these by 3. Okay, that turns my factor into 3 does not divide into 2, so I'm going to take the 3 and put it in front of the x. So I get 3x plus 2. Okay, and then my second factor would become x minus 4, because 12 divided by 3 is going to actually give me 4. Okay, so I turn now the y into 0. Okay, so I'm going to move this over here so you can see what's going on. So right now I have 0 is equal to quantity, my distinct factors are 3x plus 2 and x minus 4. Okay, well this one's easy to find the zeros for. That's going to be positive 4. So I know one of my zeros is going to be positive 4. Okay, but this other one, we have to maybe do a little bit of work to figure it out. So here's what we do. We take the distinct factor, 3x plus 2, we make it equal to 0, because that's what I want, and then I just solve this to find out my 0 for this distinct factor. So I'm going to subtract 2 from each side. That will cancel out the 2's, and then I'll get 3x is equal to negative 2, and then I'm going to divide both sides of the equation by 3. So we get x is equal to negative 2/3. So that means my zeros are 4 and negative 2/3. Okay, so that would be my zeros for number 7. All right, number 8, 6x squared minus 13x minus 5. So once again, I have this leading coefficient of 6. So to factor it, I get rid of it, and I multiply it by the last term. So that creates my trinomial as y equals x squared minus 13x minus 5 times 6 becomes 30. And now I'm going to factor this trinomial into two binomials. It is a minus binomial, so that means my trinomial, that means my binomials will become x plus and x minus, okay? And then I'm going to take my c value, which is 30, and I'm going to figure out what my distinct factors are, I'm going to write out all the factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay, now which one of those can be added or subtracted together to make 13? Well, that's going to be the 3 and the 10. All right, now the question is it, or it could be the 15 and the 2, excuse me, and it's going to be the 15 and the 2. And the reason is because I have to have a plus and a minus. And the only way I can get that is to go minus 15 plus 2. That gives me the negative 13 that I need. So this is going to be x plus 2 and x minus 15. Okay, so those are actually my distinct factors there. Okay, so now I'm not done, because now I have to divide both of these numbers by the number that I multiplied by at the very beginning, which was 6. So I divide both of these by 6. Okay, can 2 be divided into 6? No. But can we reduce it? Absolutely. So this reduces to 1 over 3. So that means my first factor is going to be 3x plus 1. I take the 3, I move it in front of the x. So I get 3x plus 1. My second factor, distinct factor, can 6 divide into 15 evenly? No. Can we reduce it? Absolutely. It reduces to 5 over 2. So that means I take the 2 now, I move it in front of the x, so my second factor becomes 2x minus 5. Okay? So now I'll write it over here. I have 0 is equal to, one of my distinct factors is 3x plus 1. My other distinct factor is 2x minus 5. And now I need to find the zeros of each of these. Well, the way I find the zeros is I take each one of my distinct factors, I set them equal to 0 because I'm trying to find the zeros, then I solve each of them, and I'm probably going to get a fraction. Okay, so solving 3x plus 1 equals 0, I subtract 1, I get 3x equals negative 1. I divide both sides of the equation by 3, so I get x is equal to negative 1/3. That's one of my zeros. X is equal to negative 1/3. Okay, then my other zero, solving 2x minus 5 equals 0, I'm going to add 5 to both sides of the equation. I get 2x is equal to 5. I divide both sides of the equation by 2, and I get x is equal to 5 halves, or 5 over 2. So that means my two zeros of my equation are x equals negative 1/3 and x equals 5 halves. All right, moving on. Number 9. Now, when we in part 3, so 9 through 14, we're going to be finding the zeros when the bx term is missing. Okay, so if you notice, we don't have a bx term here. So what we do when we're solving this equation out is we just want to solve the problem for x. So if I told you x squared is equal to 9, how do you solve that? Well, you just take the square root of each side. So what's the square root of x squared? That's x. What's the square root of 9? That's 3, but remember, it has to be positive and negative 3. So what are my zeros? They're right there. My zeros for number 9 are positive 3 and negative 3, and that's how we write that. Remember, the square root of 9, a lot of students just say it's 3, but remember, it's positive 3 and negative 3. Okay, number 10, 3x squared is equal to 48. So I'm going to divide both sides by 3. That's going to give me x squared is equal to 16, and then I'm going to take the square root in order to find my zeros. Okay, so I'm going to get x is equal to the square root of 16 is positive and negative 4. So there's my zeros for number 10. All right, number 11, negative 6x squared equals negative 216. So I'm going to just solve this for x. So I'm going to divide both sides by negative 6. That would create the equation x squared is equal to 36. And then I'm going to take the square root of both sides of the equation. So my zeros would be x is equal to the square root of 36, which is positive and negative 6. Okay? In number 12, we have x squared plus 1 is equal to 101. So I'm going to subtract 1 from each side. That would give me the equation x squared is equal to 100. And then I'm going to take the square root to solve for x, and that'll be my zeros. So what's the square root of 100? It's positive and negative 10. So my zeros are positive 10 and negative 10 in number 12. All right, number 13, 3x squared plus 6 equals 54. So I'm going to isolate the x. I'm solving for x, so that my first step would be to subtract by 6. 6's would cancel. I now have the equation 3x squared is equal to 48. Then I'm going to divide both sides of the equation by 3. That would cancel out the 3's, and I would get x squared is equal to 16. And now I need to get rid of this second power, and I do that by taking the square root of both sides of the equation. Okay? So the square root of x squared, really what happens is that square root cancels out the power of 2. So I get x is equal to square root of 16 is positive and negative 4. So those are my zeros for number 13. Okay, last one, same idea as number 13. My first move, my first step is subtracting 18 from each side of the equation. That would cancel out those 18s. That would create the equation 2x to the second power is equal to 162. Then I'm going to divide by the coefficient 2, not the exponent 2, the coefficient 2. So I'm dividing by 2. That would cancel out those 2's. And then I would have the equation x squared is equal to 81. Now I need to get rid of that second power. So mathematically, how I do that is I take the square root of both sides of the equation. The second power will cancel out the square root symbol, and that'll leave me with x equals, and then what number times itself equals 81? That's the square root of 81. Well, positive 9 times positive 9 is 81, so that's why it's 9, positive 9, but also negative 9 times negative 9 is also 81, so that's why the answer has to be the plus and the minus 9.